Good evening, everyone. We are live now. I'm starting the class. We are live now, and I'm starting the class. Now, let's start today. Force, momentum. I'm sharing the link as fast as possible so that you can join the class. Share now. Class started. Beta. Good evening, Vida. So now I'm starting the session and send the link to the group. I have already shared, but I don't know. Now let's start the class. Now, last class we were discussing about force, correct? We learned about force, we learned about momentum, we learned first law, Newton's law of motion. In that first law of motion we understood, and then second law of motion we understood. We understood that force is what? Force is a vector quantity or a scalar quantity. We came to know that force is a, come on, say force is a vector quantity or scalar quantity. We came to know that force is a vector quantity and it is exactly its SI unit is Newton. Understood? So today little bit of work we are going to do and then we are going to start the work. Okay. So now first few questions we are going to encounter before going to the session. So let's start the questions. First few questions I'm going to ask and we are going to discuss these questions from the beginning. Let's see the first question. Total many questions are there. It will be very beneficial for you. Come on, let's start. Bhavya, good evening, Peter. So let's start the session. Which of the following is not a force? The first question is which of the following is not a force? So I think last class we have discussed, we will just give a short review. Yes, temperature is not a force. Exactly, magnetic pull or push, when it is attraction or repulsion, it is considered as force. Frictional is an opposing force. Gravity is an attracting force, correct? Because it attracts the object which is falling towards it. So all these three A, B, C are type of forces, but temperature is not a force. It's the state of the body or the particles that is exactly receiving heat from the external bodies. Receiving heat from the external bodies. Now let's go for the next one. What is the direction of force? I'm starting. What is the direction of force of friction? Same as motion. Everyone present in online, start answering the question. This is question number 2. Same as motion, opposite to motion, perpendicular to motion, downward. See, out of this, the correct answer is Nityam, absolutely correct. The correct answer is opposite to motion and option is B. Absolutely correct. Why beta? Because it is exactly doing what? It is opposing the motion. Frictional is an opposing force. I hope you might have understood this one. Come on, go for the next one. Now we will go for the next part. Force and inertia, MCQs. Force can only stop a moving object, only change the shape of an object, change the state of motion and shape of object, only move object. What is the correct answer? Where is the more options presently? The correct answer is C. What is the correct answer here? C. Correct answer is C. It changed the state of motion. Absolutely correct. It changed the shape of motion and shape of object. Now we will be going to the next question. 1 Newton is equal to what? 1 Newton is equal to what? Absolutely. Very good, Nityam. Super, beta. Bless you. So here 1 Newton is equal to 1 kg 1 meter square. 1 kg 1 meter square. 1 kg 1 meter square, and we will do it. Come on, go for it. So 1 Newton is what meter? We know that force is equal to mass into acceleration. Mass is in kg, acceleration is meter per second square. So what is the answer? The first option. Yes, the answer is exactly what? The answer is computer. 1 kg per meter square. 1 kg per meter square. That is the correct answer here. So here option is A. Option is A. Nityam, here option is coming as A. Before option, just go to the like button, press the like button and get the answers, please. Okay, so answer is A. Now let's go to the next part. Newton's first law is also known as law of inertia. What is Newton's first law known as? Inertia. Newton's first law is known as law of inertia. Now my question is, give one example where you can prove that Newton's first law is also known as law of inertia. Give one example to prove that Newton's first law is known as law of inertia. Just prove this point that Newton's first law is law of inertia. How can you prove that Newton's first law is law of inertia? Yes, Nitya, answer is absolutely correct. But I am asking a question that Newton's first law is law of inertia. How? Because Newton has explained one very important point, and that point what Newton has explained, that the body which will be at rest will remain at rest. The body which will be at motion will be at motion. Understood? And the body which will be exactly in uniform, and the body which is continuously changing its direction will keep on changing its direction until and unless an external force is applied on it. Understood? And then in inertia, what we are reading is, in inertia, what we are understanding is, given an object, listen very carefully, in inertia, what we are learning is, given an object is kept on rest, the object will be kept at rest. Why? Because the object need an external force. Understood? So since the concepts are exactly to the same, and inertia explains most of the content related to Newton's first law of motion, is that's why Newton's first law of motion is also considered as law of inertia. Newton's first law of motion is also considered as law of inertia. Come on, get back to the answer. Better get back to the next point. A book remains at rest on a table because no force acts on it. It has no weight. Forces are balanced. It is weightless. What is the correct answer? Come on, move for the answer. When a book is kept at rest, remain at rest on a table because of what thing? So I'm going to keep a book on table, and the book will be kept at rest because of what? Come on, go for this. Write the answer. Tell the answer. So this is the book, and the book is on table. So what will be? Actually, this force, or this force. Where the forces directions are? Exactly, which is the direction of force? The correct direction. Answer is Tabassum. What is the answer, beta? No force act on it. Tabassum, understand it very nicely, beta. Force will be acting on it. Remember this. Force will be acting on it, but the forces are balancing each other. The forces are balancing each other. That's the correct answer. So forces are balanced is the correct answer, beta. Forces are balanced is the correct answer. So can I repeat my content, please, so that children can understand nicely? When a book is kept on a table, the book will be remain at rest. What is the reason behind it? The forces are balanced. And beta, how the forces are balanced, bacha? The forces are balanced because first is normal will be acting on it, upward direction, gravity will be down, and if their force will be exactly exerting this direction, friction will be there. So force is here, friction will be here. So from all the four directions, it is exactly balancing the force. So once it is balancing the force, it is exactly called as balanced force. It is called as what, beta? Balanced force. It is considered as what? Balanced force. I hope you might have understood. So balanced force will not allow the body to have motion. Balanced force, the body is exactly considered as rest. Understood? So most of the body which is having a balanced force will be considered as either at rest or in uniform motion. Understood? So uniform motion or in rest. Got it? I hope everybody understood equal and opposite forces from the table. Absolutely correct. So here all the content we have explained and understood. So now let's check this one for the next question. Get ready for the next question. Question number 6, the number just, if the body is moving at uniform speed in a straight line, then force is acting on it. No net force is acting, friction is acting, weight increasing. This is exactly some question where you need to think nicely, beta. Can you tell me what is the answer here? That's what few seconds before I have answered. Come on, children, you can go for it. Force is acting on it. Come on, everyone, try to answer the question. Come on, be a part of it and answer the question. Say what is the answer here? Children, you can answer the question. Think and answer the question. Okay. Arunisha is telling B is the option. Hey, चलो मस्ती मत करो, आंसर करो. मस्ती बाद में करेंगे बेटा, पहले आंसर. So no net force is acting, friction is acting. See, that is what we have understood, that if a body is exactly at rest or it is at uniform motion, it will continue its state of rest or a state of motion. Understood? It will continue its state of rest or state of motion until and unless an external force is applied on it. So here beta, what is our answer is no net force acting. Here option answer is B. What is the answer here? Answer is B. That is no net force is acting. Are you understanding? Why? Because here external force is not at all there to change it. So if external force will be there, then only we can think about change. But here no external force is there. So 100% there is no change. I hope you might have understood. So better the see, if a body is moving at uniform speed in a straight line, then no net force acting on it. Understood? Okay, very good. चलो तुम भी, तुम्हारे साथ मैं भी, because mango is my favorite. Okay, now come on. Question number 6 done. So beta, what is the answer? The answer is no net force acting on it. So if it is coming out of uniform motion, then only we will understand that there is some external force applied on it. I hope you might have understood this one. Come on, go for the next one. Question: inertia depends upon. Inertia depends upon. Chalo answer karo. Inertia depends upon mass. Very good. Because inertia is exactly totally dependent upon the incapability of a body to change its state of rest or motion until and unless an external force is applied on it. And when an external force is जरूर 100% आएगा. चलो, so mass, understood ना बेटा? The answer is coming as mass. चलो, you called me sister, that's a very big thing. So inertia of motion means body at rest remain at rest, body resists motion, moving body continues to move, body change. What is the answer? Come on children, what is? Come on, let's see who can answer this question. Come on children, answer this question. Second option. Second option. Body at rest remain at rest, body resists motion. B. Body change direction, body moving, body continues to move. Wow, this answer anyone? Chahil, good evening beta, very late Chahil. Come on, enter and start answering the question. You people can do it. Child has given option C as answer. Moving body continues to move. So this is not C. Likhe, the correct answer will be answer C. You people have not read. Child has only considered the most important point. Come on children. First you see the question properly. Come on, look here. Inertia of motion means, what they are asking? inertia of motion means. Here it is not inertia of rest. If they might have talked about inertia at rest, that time we could have considered that it is remains at rest. We could have got body resist motion. These two can be considered for inertia at rest. This can be considered when inertia, the body is at motion and moving in a direction. Correct. But they are telling inertia of motion means. So here, first one and second one we cannot account. Please pay attention here. First one, it is for rest. But here the question is for motion. Understood? Here, body resists motion. This is exactly for rest again. This is for rest again. Like this only you people are doing mistake in exams. Are you understanding? When you are reading a question, you must read the question according to the content. I hope you might have understood a bit. Now say, body changes direction. This is for inertia of direction. So this is also for not there because their main concept is motion. So when their main concept is motion, yes, after that only you change beta. So C is the correct answer. That is, moving body continues to move because of inertia of motion. It will not stop. Understood? Because net force is 0. Where no external force is there. Then only you need to change it. I hope you people are ready. This is the way to answer the question. Now come on, go for it. Which one is a non-contact force? Question number 11. Which one is a non-contact force? Hello, Krish. Which one? Krish, hi beta. Let's say. So, which one is a non-contact force? Beta, what is the meaning of non-contact force? Where without contact you are experiencing force is considered as non-contact force. So here पूछ क्या रहा है? What they are asking? Which one is a non-contact? Means without contact, the force you are experiencing. Understood? That is called as what? Non-contact force. Okay. So now let's see friction. Which one is there? Friction is a non-contact force? No. Ask better. पढ़ाई से पूछियो. समझ में आया? Second, normal force, tension, magnetic force. So what is the correct answer? Come on, say A, B, C, D. So here, what is the answer, beta? See, friction is a contact force. ये सब जानते हैं. Friction is a contact force. Friction is what, beta? Friction is a contact force. Come on. Friction is a contact force. Second one, come on, answer karo. Normal force is again contact. Tension is again contact because string में कुछ tie कर दो. The string is exactly holding the object. The object will be experiencing. So here also, whatever we are learning, everything is contact. But magnetic without contact also you will be experiencing. If you take a magnet north pole, another magnet north pole, you will try to bring near them one magnet, another magnet north pole, means what they will do? They'll repel. So without touching in contact, without coming in contact, they are exactly repelling or attracting. So 100% the answer will be absolutely, Arunisha. The answer is D. Bhavya, Chahil, everyone start answering the question. 10th का क्लास बेटा सुबह का हुआ था और आज का क्लास बहुत अच्छा हुआ था, उसको ले लेना. और कल शाम का होगा, मैथ्स का होगा, जरूर ज्वाइन करना ट्रिग्नोमेट्री के लिए, ठीक है? So beta, what is the correct answer? D. Now go for next question. Which of the following is a contact force? Gravity, electrostatic, magnetic, and friction. Chalo, gravity is also because without that itself, okay? Without that contact itself, we are experiencing. So gravity is a contact force. Electrostatic force is a contact force. Magnetic force is a contact force. No, all these three are non-contact force. भाई छत से कूदो तो जब तक नीचे धरती पे नहीं जाओगे, still you are falling from terrace, till you will not in contact with the floor, you are falling now or you are falling only. So that means after that is not exactly coming in the contact. Understood? So that is a case of non-contact force. Again, next, electrostatic. You rub, you take a pen and you rub on your hair. You let the object charge. Understood? Now the charges will be present. It will attract the bits of paper. Understood? So attraction means what? After coming and touching, it is not attractive. Before some few the centimeter distance or few, it is exactly starting taking the bits of paper. So again, it is exactly non-contact. Second is magnetic force. Magnetic force, just few seconds before we learned, it is non-contact. So now finally answer, what is the answer beta? Friction. So friction is a contact force. Absolutely correct. So here, if somebody will be asking you what is the correct answer, we will answer friction is the correct answer. Come on, go for the next one. See, I want everyone to answer. The relation is given by Newton first law, second law, third law, law of gravitation. The relation is given by you. The answer to the question is not correct. Relation between, see, I am just completing the question here. Some mistake is there. See, the relation between force and acceleration and mass means that is momentum or change of momentum. We will be exactly. I'm just changing it. So momentum is explained by which law? Rate of change of momentum. Rate of change of momentum. So rate of change of momentum is given by, explained by Newton's second law. Understood? So linear momentum is exactly explaining which law of motion? Second law of motion. Rate of change of momentum. What was Newton's second law of beta? No, second law of motion? Newton's second law of motion was telling a very important point, and that is rate of change of momentum is directly proportional to, कल का टाइमिंग बेटा शाम को 6 o'clock 5:30 से एक बार चेक कर लेना, 5:30 to 6 o'clock, 6 o'clock मैथ्स का क्लास शुरू हो जाएगा. ओके, 6 o'clock मैथ्स का क्लास शुरू हो जाएगा. और बीच में एक क्लास लेने का छोटे छोटे शॉर्ट्स बना करके भेज रही हूँ मैं, क्योंकि एग्जाम आने वाले हैं ना. Now look here beta, shall we start beta? So now look here. So second law of rate of change of momentum is directly proportional to force. Rate of change of momentum is directly proportional to force. So that is exactly explaining what? Newton's second law of motion. It is explaining what? Newton's second law of motion. So now come on, go for this question. Newton's third law of motion is applied when a ball is at rest, a rocket launches, a body is sliding, weight is measured. Which is exactly, and what is Newton's third law of motion? See here, where Newton's first law of motion explains inertia, Newton's second law of motion is rate of change of momentum is directly proportional to force. Newton's third law of motion says every action is having an equal and opposite reaction. Every action is having equal and opposite reaction. So exactly when a rocket is launched, just remember this one, I'll explain here. So action and reaction will be there. 100% action and reaction will be there when the rocket is exactly launched. So first what is exactly happening there is, see, when the rocket is getting launched, or any Deepavali crackers also, when you are bursting here is, what you are doing, you are exactly putting what you call fire here. Now what will happen? Motion is here, action, the rocket will be moving upward direction, reaction is exactly the force. The force is exactly given which direction? Down. And where is the action? The object will go up. Understood? So action and reaction forces which are opposite to each other will be acting on a body. So when action and reaction are oppositely acting, so that time it will be exactly considered as Newton's third law of motion. So one simple example I'm giving you, don't laugh. Just for joke I'm doing it. The most simple thing I'm explaining you and your friends are fighting, correct now? Now you went and slapped your friend. And don't need to slap here now. So you went and slapped your friend. The moment you went and slapped your friend, one thing happened, and that is you slapped means your friend has experienced some pain, correct now? But beta, you also experienced pain. Because contact, the moment you contacted, till here you are moving your hand, nothing is happening. The moment you contacted your hand, what happened? Exactly, contact force, here action and reaction happened. So force, your friend's face is exactly what, again see, because this is motion, suddenly the motion came to rest, means you hit. Understood? So his force is returned to you. So that means what? Your action and reaction both are there. That's why in return you will feel pain in your hand. Correct now? So if you are beating someone, you are experiencing force, opposing force. And that is exactly absolutely correct, because when you are beating anyone, you are experiencing force. And that experiencing force is opposing. I didn't understood Krish क्या बोल रहा है बेटा? So I hope you might have understood here. Huh? So action and reaction. Did you understood? Huh? Shweta, understood both of you? Again I forgot your name. Sweta and Sumita. Smita. हाँ. So Sweta and Smita, understood everyone? क्या हो गया बेटा? Krish, चल चल बताओ. I hope you might have understood now, beta. So whenever we do any action, there will be an reaction. So that is exactly coming under what, beta? That is coming under action, and reaction is Newton's third law of motion. Understood? So Newton's third law of motion is applied where? Rocket launch. Rocket launch. Now, if the net force on an object is zero, its acceleration is, come on, say. If net force of an object is zero, its acceleration is. What will we see? Net force is zero. Okay, if a body is exactly having no external force applied on it, what will be its acceleration? What is acceleration, beta? What is its acceleration? Chahil, first answer is given by Chahil, and then Anu. Okay, after that Bhavya has given the answer. आई एम नॉट इग्नोरिंग यू, तो क्या क्या लिख रहा है पहले ये पढ़, तो कूटूंगी मिल जाएगा, थोड़ा अच्छे से तो लिख, समझ नहीं आ रहा था क्या लिखा है इसलिए नहीं पढ़ पाई, ढंग से लिख, आई विल लिख, ये बहुत विल एंजॉय। मैं गेम नहीं खेलती, मुझे कैसे पता बताओ ना बेटा, लुक हियर, so here acceleration, so if force is equal to mass into acceleration, so net force is zero, body will have mass will never be zero. I am at rest does not mean that I am having zero mass. I am at rest means it does not mean that I am having zero mass. I am at rest means I am having mass, but net force is zero, acceleration is also zero. Understood? So net force is zero, acceleration is also coming as zero. I hope you might have understood this one. Come on, go for the next one. Come on, we'll go for the next one. Chalo. Unit of momentum. Chalo, shurveer log bata do. Answer is unit of momentum. Come on, give the answer as fast as possible. Answer is A, kg meter per second. What is momentum, beta? Momentum is mass into velocity. Very good. So here two people have given the answer. Third person is sleeping. All three these people are sleeping. Come on, jaldi batao. They have given the answer. What is unit of momentum? Beta, momentum. अब फूटूंगी, चेक कर तेरे पास चिपकी हुई है ना, लुक हियर बेटा, मोमेंटम इज व्हाट बेटा? मोमेंटम इज इक्वल टू mass into velocity. Momentum is equal to mass into velocity. So mass unit is what beta? Kg. Velocity is meter per second. So what is the unit beta? Kg meter per second. Answer is A. Kg meter per second. Answer is what beta? A. So unit of momentum is kg meter per second. Now we will go for the next one. SI unit of mass is Newton. ऐसा यूनिट ऑफ मास न्यूटन, वाह सुपर, कटिश क्या खाया सुबह, व्हाट इज द आंसर? कम ऑन आंसर, ऐसा यूनिट ऑफ मास gram, pound, Newton, kilogram. The first correct answer is exactly coming as, okay, Aru has given the answer D. Okay, child rectified the answer. Bhavya, where are you? Where is Shanvi? Okay, the correct answer is D. Where is Sam? The correct answer is D. Understood? Krish, I'm having a group beta. In our coaching, we have group of students. Online students separated, offline students are separated. We have group beta. You have to register there. उसको छोड़ दो, उसको बहुत कूटने का मन है अभी, उसको मार करना है. Come on. Which object will have the least inertia? Train, truck, bike or ball? Come on, answer. Krish, अब बताएगा. Question 17. Which is having? हाँ, Krish. Which will have less inertia? Come on. Train, truck, bike, ball. हाँ, Krish. वेर हमारे कोचिंग की ग्रुप में बेटा, तुमको उसके लिए कांटेक्ट करना पड़ेगा. डी. Answer is D. Correct na beta? How much inertia? You need to understand that object inertia will be more if its mass is more. Understood? So here maximum inertia will be which one? Train or truck? Bike, leave it. Maximum inertia will be for train. Minimum inertia will be or least inertia will be for ball. Because how much is the mass? How much is the mass? That much is the inertia. Means the body will not at all move until and unless a heavy external force is not applied on it. So here maximum inertia is for train or truck? Train. Minimum inertia is for. Understood? So maximum is for train, minimum is for ball. I will come to know you are active in the class or not if options you are not giving correctly. Okay. So you need to press the live button and then you are exactly going to answer the question. So if I am not getting any answer from you, means that student is considered as absent in the class. Okay. Now come on, go for the next question. What is the action in walking? Foot pushes ground, ground pushes foot, foot slides, foot bends. This is a very technical question. Come on, answer this question because this is a very technical question. Come on, go for it. Option give, please. Option give, please. Foot. What is the action in walking? Foot pushes ground, ground pushes foot, foot slides and foot bends. So 100% foot cannot slide and bend. Very good. Now we'll check. Now better see. Action and reaction this way. Yes, 24th answer is A. Child has given answer, but here offline student already given answer as A. So you understand one thing. So foot pushes ground. Yes. Now Bhavya and Aru has given the answer. Now please remember one thing. Foot pushes ground. Where is action and where is reaction? Actually, it is explaining which law of motion? Third law of motion. Which law? Newton's third law of motion is explained here. Action and reaction. So when you are putting your foot down, what will happen? The moment you are putting, what happened? You are pushing the ground. In release, what will happen? The other leg will be automatically releasing and you will be exactly moving forward. Correct? No? So action and reaction will be there. Understood or not? So here, the foot is pushing the ground. After that, in reaction, the ground, the second part is exactly, the ground is exactly not pushing it outward. You are itself moving in the forward because reaction force will let you go forward. Understood? So the correct answer is 24th correct answer is what? Foot pushes the ground. The correct answer is A. When a carpet is beaten with a stick, first particle comes due to gravity, friction, inertia, or force. Child has already given 25th. मैं बता रही हूँ तेरे को, रुको. Now look at gravity, friction, inertia and force. What is the correct answer here? A. When a carpet is beaten with a stick, here first answer was given by 25th. First answer was given by Chahil. After that, Chris, ma'am, ABC up offline class B. हाँ बेटा, मैं ऑफलाइन क्लासेस भी लेती हूँ. सो चाइल्ड इज गिवन ऑप्शन सी. छिपकली वेट बता रही हूँ तेरे को. ऑप्शन सी, ऑप्शन सी, ऑप्शन बी. ना चाहे यू सी अंडरस्टैंड वन थिंग बेटा, दिस इज inertia only. First you were correct, after that you got diverted. You pay attention here, listen very carefully. It is inertia. Why inertia beta? See, the carpet is at rest. The carpet is at rest. Now you started beating the carpet. Now the carpet will come in motion, but the dust particle is still at rest. So what will happen? The dust particle will fall down. Are you understanding this concept? Yes, we already discussed this example. No problem, Kisha. Third law, I just explained. We will do it. Okay. So, but in between, because that question came now, so we discuss. So, 22nd question: tendency of a body to remain at rest is called as. This question is. Come on. Repeat, beta. Unnati. See, tendency of the body to remain at rest. Remain at rest means what? The body will remain at rest. It will not at all move. Understood? And this will only come, the body is at rest. And that is considered as inertia at rest. Understood? Inertia of rest. Absolutely correct. Inertia of rest is the correct answer for 22nd question. Come on, go for it. Okay, momentum of a body depends upon mass and velocity. Momentum of a body depends upon mass and velocity. Unnati, good evening, beta. Good evening, Unnati. So, momentum of a body is mass and velocity. Product of mass and velocity is momentum. Very good. Absolutely correct, Unnati. Krish, everybody. No problem, beta. An unbalanced force can cause no motion, constant speed, change in velocity, increase in mass. Think very nicely and give the answer, beta. An unbalanced force can cause what? No motion. 100% unbalanced force will cause change in motion. So A is not the correct answer. Let's see. So this is not possible. Constant speed. Unbalanced force will create constant speed. Not possible. Understood? It will not be possible. So here also it is wrong. Increase in mass. How can mass be increased? Mass is a constant intrinsic property, so mass will not be changed. So what will happen? Change in velocity. Velocity change will create change. So 100% the answer is considered as what, beta? 20th answer is C. 20th answer is C. I hope you might have understood. 21 answer is what, beta? 21 answer. Let's check this one out. What is the answer? B. Okay, Amrish is telling 21 answer is, come on, Unnati, go for 21th answer, beta. A man pushes a ball, but it does not move. Which law is this? First law, second law, third law, none of this. Hey, think very nicely. I think yes, yeah. Think very nicely and give answer. मैं चेन्नई में हूँ रे, कृष्ण. Inertia. All four options. 1 minute you are telling A, then after 2 minutes you are saying B, then you are saying C. After some time you are saying D. One answer give please. One at a time. 23rd answer. 21st answer. Give. 21st answer. Let's check this one out. So now Shahil and Aru has made up their mind. They are not going to change their mind. They are only saying C. Like this only I want. Huh? Now let's see beta. C. So here, first the man pushes a ball but it does not move. None is not the answer. First law of motion, no. He is applying force. is applying force. Force is exactly applied. So here first law is not there. Second law, momentum has to be there. Here motion is not there. So here equal and opposite reaction is countable. Understood? For every action, equal. Unnati, correct only, beta. Huh? For every action, there is equal and opposite reaction. Yes, Krish. Where are you from? Now look here. You understood now or not? You applying the force and how much force you are applying, that much opposing force you are experiencing. So action and reaction is there. But wall is not at all moving. So your wall is not moving, action and opposing reactions are exactly acting on it. So 100% option is what, beta? C. So here answer is C. Come on, go for the next one. This. What is the momentum of a body of mass 5 kg moving at 2 meter per second? Share. This question is question. Options Sonama, please. What is the answer? A. So here offline children has given the answer. What is the answer here? A. Let's see. Okay. Chahil, today Krish मैं ignore कहाँ करी रे? Answer तो क्या तेरा? मैंने पूछा कहाँ रहता है? बता. So what is the answer here? Come on, go for it. Go for it. Answer is A. How? Because we know that momentum is equal to mass into velocity. Momentum is mass into velocity. So since what is the mass given to you, beta? 5. What is the velocity? 2. 5 to the 10 kg meter per second. So what is the answer, beta? A is the answer. Did you understood it? Very good, Unnati, Bhavya. Everyone absolutely correct. Let's go for the next one. Balance force can move a body, stop a moving body, change shape, accelerate a body. Bah. This is a very good question. Answer it very technical question. Now you answer. Think. Without doing Google, you answer the question. Okay, child has given the answer as B. Balanced force can A. Balanced force can stop a body. How can it be possible? It's a balanced force. Unnati answer B. Some are telling Unnati has given us option B. Some are telling option C. Chahil change shape. Okay. Bhavya is telling A as answer. But first understand, balanced force cannot move a body. Unbalanced force can only move a body. So the first option is a wrong answer. First you understand. First you go technically and then answer the question. Here, balanced force cannot move a body. Not possible, boss. Balanced force cannot move a body. Unbalanced force only can move a body. So you must remember this one. Unbalanced force can only move a body. So first one is totally no. Understood? Stop a moving body. How can a balanced force stop a moving body? When it cannot start, it cannot stop also. Balanced force means it will be at a state of rest or it will be at a state of motion. No, both of them are not possible. So second one is not possible. Acceleration is exactly motion only. Understood? Acceleration is also a type of motion. So here this is also not possible. But it can change the shape. When we will be applying a balanced force on a body from all the direction, the body will be deformed. Correct, na? So that is exactly possible. Change of shape is possible when we will apply balanced force from all the direction. Like dog, in dog you will be. No problem, Unnati. You tried, but you people are learning now. Learning, we make mistakes. Sometimes I am also mistake, but we have to learn. The process is learning. Learning itself says that we are not perfect. We are learning from our process. So that's a very good thing that you people are answering. So hats off to you guys. You people are answering first. Understood? Because we people are also having some doubts. Means we are doing mistakes. Correct? Mistake is law of nature, beta. So now listen. Answer is what, beta? C. The correct answer is what? C. And C is explaining that the change of shape will be there when from all the direction you are exactly experiencing a force. Come on, we'll go for the next question, Peter. We'll go for next question, question number 32. A body remains in uniform motion if it is pushed, force is applied, no net force act, shape changes. Come on, this is a very technical question. Answer this question. Come on, answer it. Come on, this time try. Every time question is a try only. Understood? So correct answer is what, beta? Understand, body remains in uniform motion. When a body is remaining at uniform motion? When no external. See, Earth is rotating on its axis. Na? It is not at all changing its what you call motion. Whatever axis it is moving, it is kept on moving because no external force is applied on it. Understood? So it will change when there will be some disturbance. Correct now? So till there is no disturbance, it will not change. So you need to remember it. So beta, everybody is writing option C as answer. Let's check. It is pushed. A body remains uniform when it is pushed. No, 100% exactly. Do not. It is going to create problem for its motion. So if it is pushed means it is not possible. Force is applied means uniform motion, no force is applied. This already we know. Now shape changes, no, it is not possible. So no net force act. No net force act means there is no external force to disturb the uniform motion. So answer is C. What is the correct answer, beta? C. Means whatever is at rest remains at rest. Whatever is at uniform motion remains at uniform motion. Why? Is there any external force? No net force. Net force means the disturbing force is not there. Understood? The disturbing force which can unbalance is not there. I hope children you might have understood. Now, Newton's third law of motion explains action and reaction. Was Geo. Very good. Everybody, please answer this question. Question number 33. Very good. That's very quick. So, three of you have given the answer. The answer is C. Action and reaction. Action and reaction. So, action and reaction is Jagadish absolutely correct. Nice entry with a correct answer. Super. So, answer is absolutely correct. We will go for the next one. Come on. A body is moving with constant velocity. What is the net force? Wow. This is a good question. Come on, go for it. I will count who has given answer first. Child option down. Very clever. Option down. Okay, child has given option as A. Bhavya, Aru has given option A. Come on, children. A. 0. Unnati, where are you? Yeah? Answer. 0. So what is the correct answer here? Beta, look here. What is the meaning of constant velocity? Come on, check this one, beta. What is the meaning of constant velocity? When the velocity is not at all changing. Understood? Constant velocity, first to understand what they are asking from you. Then only you will be able to answer it correctly. What is the meaning of constant velocity? Constant velocity means when the velocity is not at all changing. What is constant velocity? When the velocity does not change. Understood? So here, same speed also you can see in a particular direction because velocity is a vector quantity. The change of speed in a particular direction. So here we'll see initial velocity is 60 meter per second. Final velocity is also 60 meter per second. Initial velocity is also 60 meter per second and final velocity is also 60. So it is called as constant velocity. Here velocity is not at all changing beta. So since velocity is not at all changing, it is considered as what? Constant velocity. Means you are at point A with 60 meter per second. Again you are going to point B with same 60 meter per second after 5 minutes. Understood? So at A, what is your velocity? 60 meter per second. At B, what is your velocity? 60 meter per second. In both locations, your velocity is same. So at A, what is your velocity? 60 meter per second or kilometer per hour. And here B is again 60 meter per second. In both the location, the velocity is same. Then what will be the acceleration, boss? Here we need to find acceleration, na? So our acceleration will be what, beta? V minus u by t. Got it? Here V is what? 60. Again 60. Time is how much? 5 minutes. So 5 into 60. So now but here 60 minus 60 will become 0. So what is our acceleration? For constant velocity, acceleration is 0. For constant velocity, acceleration is 0. So your acceleration is 0. So for constant velocity, acceleration is 0. So force is equal to mass into acceleration. So here mass is same but acceleration is 0. So here force will be exactly what, beta? Force will be 0. Acceleration is 0. Force will also be, no net force will be there. I hope you might have understood this very technical. The momentum of an object increase when? Increase. Momentum increase when mass increases, mass decreases, velocity increases. See, mass of a body, we learned a very technical point. We learned that mass of a body does not change. Mass of a body does not change. Mass of a body remains the same. So what can change is velocity. So if velocity will increase, what will happen? Momentum will increase. Momentum will increase. So momentum increase when velocity increase, momentum decrease when velocity decrease. Understood, beta? So it's the game of velocity because mass remains the same. And all of you have given a very well deserved answer. Very good, beta. Hats off to all of you have given. So everyone, Chahil after that, okay. Jagadishan, Arunisha, Bhavya, everybody has given the answer, and the correct answer is what, beta? B. Velocity is increasing. Absolutely correct, children. Come on, go for question number 28. Come on, go and say this. Try this question out. Come on. An example of Newton's third law: ball falling, air coming out of a balloon, and balloon moves. A book lying on table or anything. Wall hanging. This is seriously a very good question. Farhan, good evening, Farhan. Good evening, Mila. Come on, come on, come on, you can do it. An example of Newton's third law. An example of Newton's third law. See, Chahal has given answer, 20th answer as A. Other answer, Aru has given answer C. Okay, here offline children has given answer as B. Okay, let's check, children. So first we will go and check the question. An example of Newton's third law of motion. See, Newton's third law is about action and reaction. Newton's third law is about action and reaction. So here what is, see, ball falling is only having action now. The ball is moving in one particular direction and gravity is exactly taking in. So reaction force is not there here. Na? Understood? When ball will be exactly hitting and then it will be bouncing, then we can talk about anything, action, reaction force. But here ball is moving. So first is not the answer. So first answer is first the answer? No, first is not the answer. Book lying on a table is exactly what? Inertia. So C is not the correct answer. Book lying on a table is inertia. Inertia is not the answer here. Wall hangings are also not, because it is exactly hang due to inertia. Rest it will keep on hanging. That is, we have already studied there. When your back will be, you're lifting a bag, the bag will be exactly balanced. Understood? In its inertia, mass. Understood? Sorry, inertia at rest. So which one is exactly the one which can be disturbing? So air coming out of a balloon and balloon is moving. So beta here why B is the correct answer, you must know that also. So when air is coming out, action is what? Air coming out. What is the reaction? Balloon movement. Air coming out of balloon is the action. The movement of the balloon in here and there direction is reaction. Understood? So action and reaction both are there. You do one thing. You fill balloon with air and after that you leave it. You will see the balloon is dancing and air is also coming out now. So from the mouth, from where you are filling the balloon, that air is exactly coming out. Reaction is movement of the balloon. I hope children you have understood this one. How is the class? Are you understanding very nicely? Correct? So now action and reaction, both forces are here. Now come on. Which quantity is conserved when no external force acts? Speed, acceleration, momentum and mass. Which one is conserved? Conserved. Which one is conserved? Means you cannot be talking about its change. See here also in board exam or any other examination, if you will see this question, 104% you will be just not thinking and just hurry burry you will answer the question. I'm telling you, in hurry burry you will answer the question. First you think very nicely and then you answer this question. Come on. First you think very nicely and then you answer this question. Come on, try this one out. No, D is not the answer. D is not the answer. Many people has given D as answer. No, think one more time. D is not the correct answer. Now change your statement. Okay, child is telling C as the answer. Now see, in examination, if this question will come, what you will do? 110% you will do mistake and come. Correct? Na? Correct? Na? 110. Give me. No, you can't answer like that. Not possible. So when such situation are there, we need to answer it technically. Swaha. Child is telling Swaha. After that, Swaha. All marks gone. Correct only you are saying. Because after that there is no recovery. Only damage will be there. Correct now? Now come on, let's see. Hey. Movement. Amrish, what is the answer from your side? Momentum. So which quantity is conserved when no external force acts? So the correct answer is momentum. Momentum is what? Mass into velocity. So no net external force is not there, means the velocity will be, mass remains same, but velocity is not at all changing. So 100% it is conserved. Momentum is always conserved. Understood? So answer is momentum. Now let's see. A heavier object has more velocity, less force, less inertia, more inertia. I don't know the answer. You people say. Let's see who gives the answer first. I have already answered this question in previous classes. Come on. Previous classes, I have already answered this question. 26. A heavier object has more velocity, less force. आयुष, आयशा एक बार फिर से सोच बेटा, एक बार देख, सोच इनर्शिया क्या है बच्चों. फर्स्ट यू थिंक इनर्शिया क्या है, इनर्शिया किस चीज पे डिपेंड करता है. Then answer will come automatically. 26 answer is A. But ढंग से सोचो तुम लोग आंसर कर पाओगे. ऐसा आंसर है बेटा, एक बार फिर से सोच, एक बार फिर से देखो बेटा. ना, A is not correct answer. A ऑप्शन हटा दो, उसके बाद सोचो. A is not the correct answer. उसके बाद सोचो. A is not the correct answer. आप सोचो. Now look here बेटा, एक बार फिर से सोचते हैं. एक बार one more time we are thinking and we are trying to understand that a heavier object has more velocity. Right? Heavier object, heavy. When we are using the word heavy, mass. When we are talking about mass is associated with which one? Inertia. So when a heavier body will be there, its mass will be more, and if mass is more, it is talking about what? Inertia. So now answer the question. What is the correct option? चलो बता दो. Now answer करो, बता तो दिया. More velocity, less force, less inertia or more inertia? More inertia. Heavier body will have more mass. More mass means more inertia. अब मेरा केजी कर दो तुम लोग 200 केजी, तो 200 केजी को ट्रक लेकर के जाएगा कि साइकिल लेके जाएगा? Absolutely correct, Aisha. First person who has given the answer correct is Aisha. The correct answer is D. So heavier body will have more mass. More mass means more inertia. पक्का समझ गई लड़की. So here, heavier body is having more mass and more mass is having more inertia. Understood? Super. Now 27th answer we take. A boy jumps out of a moving train. He falls forward due to gravity, friction, inertia or push. एक push जिसने किया यार. Inertia होगा कि क्या होगा? कर दो आंसर इसका. The correct answer is, everybody without stoppage, people are answering as C. Let's see what is the correct answer. The correct answer actually is C. Inertia, beta na? The correct answer is C. Inertia. The correct answer is C. Absolutely. Beta, inertia of motion. What it is? Inertia of motion. Because beta, when a body is at motion, because when you are exactly in a train or a bus, so inside the train or a bus, what is actually there? The lower body part is exactly in motion. You are standing and hanging, and suddenly you want to come out. Correct, na? The moment little bit the vehicle is slowed down and you wanting to come out, that time what will happen? You will jump and stand. Definitely inertia of motion will disturb, because suddenly you came at rest. Understood? Your lower body part was at motion because the vehicle was in motion. Suddenly you jumped out and standing means you came at rest. So what will happen? You will move forward, not backward. So at that situation, you have to come out and you have to maintain some motion. Then you will not at all fall. Got it? You will not fall forward. Means the moment you are jumping out of a moving vehicle, you have to run for some distance. Got it? You might have seen any person coming out of a moving train, they will be exactly moving and running for some distance. If they will move and stop, 100% they will fall forward. Understood? Why they will fall forward? Because of inertia of motion. Understood? So sudden rest will come means you will move forward. Correct now? That day we have discussed now the vehicle will be exactly suddenly when the vehicle will be stopping, you will move forward. Same way, the vehicle you are going to come out will move forward and you will fall outside. Understood now? So definitely face and all that will be swaha. Correct? So what is the correct answer, beta? Smita? Inertia. Correct, na? 27th answer is C. Absolutely. I hope children have understood. How was the session today? How was the session today? Come on. Did you understood? So we are going to put a viram, stoppage here. I think most of you have enjoyed and you have answered the question nicely. Nice, na? By tomorrow, next class we will have numericals full.